Hello all, welcome back to the another video of our BFS series. I am Umang Mawani and I solve coding interview questions. To know more about me, check my LinkedIn profile mentioned in the description. Today we will see a medium problem, binary tree right side view. The problem statement says, given the root of the binary tree, imagine yourself standing on the right side of it and then return the value of the nodes you see ordered from top to bottom. In this example, we return 1, 3 and 4 because we see it from the right side and we have to or return it from top to bottom. In the second example, imagine 1 as root, null as left node and 3 as a right node, so we return 1, 3. Now this problem follows the binary tree level order traversal pattern as you may have noticed here. So we can follow the same BFS approach. The only additional thing we will be doing is to append the last node of each level to our result array that we will return in the end. So here is how we will proceed with the code. First, we will initialize our result list that we will be returning in the end. After that, we will see if the root is null, then we will simply return our result. If the root is not null, we will create the queue of type tree node and we will add the head of the tree node into the queue. So for queue, we will be using linked list, similar to what we did in our previous problem, and queue.add. So instead of add here, we have offer, and we will be adding the root. Now we will check if the queue is not empty. So while it is not empty, we will be traversing our roots, rather the tree. So, so here we will check the size of the queue because this will help us in iterating to that particular level node. So now we'll write the for loop to traverse that particular level. And then we will take out the current node of that level. So that is simple but q.poll. And now we can check that this current node, which we have seen, should we add that into our result or not? Now to do that, we have to check if I has reached its last value or not in that particular level. That is, if it is equal to level size minus 1, if yes, then we will simply add that current node in our res. And if not, it is simply checking if the current node dot left is null or not. And if it's not null, we add it into our queue, that is queue dot offer current node dot left. And similarly, we check for the right thing. If current node dot right if is not equal to null, so we will add it into our queue because this is how we usually traverse the tree in a BFS fashion. So till here we are seeing while the loop is not empty, we are checking the size of the queue and we are traversing up to that size. We pull out the current node, and if while traversing, if I reaches the end of that particular level, that is the last node, so we add that node into our result because that is what we have to return here. So if you notice, if we start from 1, then we traverse 2. Since in this level 2 is not the last element, we do not add it. Then we have 3. Since it is the last element in this level, we add it into the result. Then we move further. In the next level, we have 5 and 4. Again, 5 is not the last one. And when we come to 4, this is the last element in this level. So we add it into our result. So once this while loop is completed, we have all our answers into the result list. So we simply return it. Let us try to run now. Okay, so this is linked list. Yeah, so here we have to return a list of integer. So we will have res as list of integer. Q will be tree node. because we are adding root and its left and right child to the queue, and your res.add will be current node.value because that will be an integer. So yeah, let us now try to run the code. It is accepted. Now let us submit, and it's accepted. So guys, I hope you understood this problem. The time complexity of this algorithm is O of n, where n is the total number of the nodes in the tree, and this is due to the fact that we have to traverse each and every node. The space complexity of this algorithm is again O of n, as we need to return a list containing the level order traversal, and we also need O of n space for the queue because we have to store them in a queue. So the time and space complexity is both O of n. If you have any queries, please let me know in the comment section and I'll be happy to answer you. Thank you so much, guys.